do one or two of these to show you how to use this, okay? We'll start off with, what do we have here? We'll start off with a battery. Lob the battery down here. Get some wires. Okay. Let's see where I can get my wires coming from. Here's some wire. Drag the wire there. Connect it. And then do there. Then we get another piece of wire. Like so. And draw it all the way up. Then we get another piece of wire. Draw it here. Like so. And get another piece of wire. And bring it down here like so. And what we have is, we have ourselves a nice, we're getting a nice rectangle going on. Go and get myself a light bulb like so. That's two different parts. See the way I rotated that there. Get some more wire. Connect it. And what we can see here is, here we go. And there is my light bulb. Okay, I think I might throw in a switch there actually, guys, if we can help it. This means I can cut it off. So what I might do is I might put in a switch as well. So here's my switch, like so. And there's another circuit, okay? And then when I close this switch, we're good to go. Okay, just want to keep that there. Now, what I can do next is, I can use my voltmeter. And this tests my volts. So this is a 9-volt battery. Okay, and if I go over here, we can also see that this is a 9-volt battery. It takes 9 volts to go from one side of the battery to the other side of the battery. Okay, the next thing we're going to do, guys, is I'm going to get us another wire, like so, and we can currently see that the voltage across the light bulb here is 9 volts. This is how much energy it takes to get through the light bulb. Now we have something called an ammeter. Where is my ammeter? There's my ammeter. And we can currently see that we have 0.9 of an amp going through this circuit. Okay? And what we might do instead, and we can see that's 0.9 of a amp all the way through this circuit. So the current is the same all the way through. Okay? Now, next thing we're going to do, guys, is I'm going to move this ammeter away. I'm going to move this voltmeter away. And what we're going to do next is I'm going to... Don't want that there for a minute. Okay, I'm going to put another break in here, like so. Now that doesn't work. I need to do that with 2 pieces of wire, it appears. Yeah, I'll do that now. Give me a second. Snippety snip here. Gonna cut this one like so. And cut this one like so. Okay. And look what I can do this time. I can join him to him like so. Get more wire. Join him to him. Get more wire. Join this one to this one. Get more wire. Join this one to this one, okay? And now I have a second battery going on. I can join this one to this one. And look what we have here. We have basically 2 lights on at the same time. This was known as a parallel circuit, okay? Now in a parallel circuit, what happens is, if we take the current again, this time the current is still 0.9 in both areas, okay? So still 0.9, and the current runs the same through the whole system. Now if we look at the voltage across both light bulbs is going to be still 9 volts and still 9 volts here. So mind if it's -9, just means you put the terminals the wrong way around. Okay, we all good there? Now, what we can do next, guys, is with this type of a circuit, the advantage of a parallel circuit is if I break something like this, I only stop one light bulb, I don't stop both light bulbs. So that's a cool advantage of a parallel system, okay? Now the next thing I'm going to do, guys, I'm just going to get rid of this one up here for a minute, like so. Don't really mind that. And I'm just going to free up my other light bulb. Now I'm going to set up what's called a series circuit, okay? And what the series circuit is, I'm going to make them go through not one but two light bulbs at the same time. So just there's my other light bulb like this. Okay, and what we have here should be a series circuit, we're hoping. I'll just get rid of my voltage there. Okay, and we're just going to connect this up. This time you can see that both lights light up and it's just simply one circuit. This time the current is slower because it has to go through, I've half the current because it has to go through two of them instead of one of them. And we can see the voltage, well, the voltage across the battery is still 9 volts, but the voltage across each individual light bulb is now 4.5. Okay, so this means that your voltage is 4.5. Okay, so that really slows things up. Now, next thing I can do is I can make this, what's it, battery resistance. If I up the battery resistance, it makes things slower. But if the battery has no resistance, it's really low. The wire resistance, if the wire has lots of resistance, we can see the electrons barely go anywhere. They're really slow. But if the wire is low resistance, it goes quite fast. Okay. Next thing I can do after that, guys, is I can introduce. Let me see, another battery. And what we can do is we can make this stronger. So look at this. Okay, get rid of this one here. So I'm going to get another battery. Attach it in here. Attach this here. And then the two of these combined. Close my thing. This time look at the voltage. To get from the far end of one battery to the far end of another battery is 18 volts, which is twice. Two batteries in line makes 9 volts each. Let's look at the light bulbs, 9 volts each. Okay, you can see another 9 volts like that. And what we can also do is I might throw some more batteries in. Okay, so I'll split here. Maybe we could throw in another battery. There we go. 13 volts. We've seen it starting to move faster. Split it again and put in even more battery power. See, to go from one end of one battery to the other end of the other battery. So that's a 27 volt battery now. And if I keep adding on the batteries, it'll make it go faster and faster. Okay, so like so. You can see it's moving even faster again. We put a brake in this battery as well. Go again. You can see that the current's going faster and faster. Okay, now I can also click on my battery. I mean, you see that's some ways of making some really cool circuits. Okay, alright guys, hope that helps.